Hello, everyone. Thank you for coming again today. So, this is the third session of DSA Beginners Bootcamp, and we'll be starting shortly. So, before that, I just want to ask that did all of you receive the emails regarding the assignments and for next steps? If you did, please drop a yes or no in the chat box. Okay. Did you guys register through that form for DSA Bootcamp form? Because all the people who registered for through that form did get an email. Because all right. So just to make sure that everyone receives further updates, we'll be sharing the form again today at the end of the session. You can just fill it out again, and we'll mail it to you all again. So yeah, I'd request Akshay sir to begin now.
Hello everyone, hope everyone is doing good. There's a power cut at my place, and also, my battery is at 50%, so we'll try to get done with as much as we can, as long as my battery lasts all right. So last time we stopped at circular queues. So we're going to have a quick recap of queues, then we'll move on to circular queues. Is everyone fine with that? Can you drop a yes in the chat? All right, so we'll first okay, just some syncing issue. Just give it a minute. All right. So let me just give you a recap of what queues are. I won't be going into the code, but I'll just give you the concept because I taught you guys the code last time. And I'll just, tell you the drawback of a queue and why we're going to use a circular queue instead. So, as you know, a queue has a fixed length. Let's say, oh, yeah, let's say 4 or 5, 2, 3, 4, and 5. So here we have 5 positions. So when the queue is empty, we all know that front is equal to -1 and rear is equal to -1. So this means that the queue is empty. So when this is the case, we're going to add a first element, say x, inside the queue, and then what we're going to do is we're going to reinitialize front to 0, and then we're going to increment the rear value and then put the value inside. So this is how you add, right? So okay, so say now my front is going to be here and my rear is also going to be here. So when I add another element here, my rear is going to move here. So as I add, rear moves, but front stays at 0. So let me just Z, A, and B, and rear. So now our rear is equal to size -1. So meaning that all the positions are filled, we cannot add any more elements. So what happens now as we delete, right? Our front is going to move. So front is pointing at Y now and X has been removed. So just because one element was deleted doesn't mean we can add another element in this normal queue, because R is at the end position, right? R is at the end position. You're not able to increment R beyond this. So you're going to delete another item. F is going to move here. two items are deleted, but you're not able to add two items to the existing queue. So this is the problem that we faced with normal queues, correct? Does everyone remember this? Drop a yes or a no. All right, so I will go on to a circular queue. A circular queue is exactly the same as a normal queue in terms of structure, but the way you code it is different. That is what makes it. Just give me a second. All right, I think I lost the piece of code. Just give me a second. Um, Wait a second. Not this one. Hmm, um, yeah, I got the code back. All right. 1 minute, I'll reshare my screen. Let me know when it is visible. Can someone drop a yes if it is visible? All right. Um, all right. So now let's look at a circular queue. A circular queue, when you think about it, it's exactly the same as a normal queue. It's going to have some memory positions, but when implementing it, you're going to implement it with another idea in mind. You're going to try to implement it like this. So, I mean, in the memory, it's still going to be stored in a straight line, but look at this index 0, 1, 2, 3, and 4. So what you're going to do basically is, so just say f is here, and you have, x, y, z, a, and b again. So now when we're deleting, we're only going to delete from f, right? So now this has been deleted. F has moved to this one. Now this is f and this is deleted. I'll just erase it. So now f has been moved and this element has been deleted. So just programmatically what you're going to do is you're going to logically say, if I am at the end position, that is if r is equal to size minus 1 and front is not equal to 0, that means some positions are free, right? So you can just say, okay, what you can do is you can just move r, you can, reassign r is equal to 0. And then what you can do is you can increment r here and you can add, say, c here. You're adding c and your r is coming here. So what happens next? Say I delete something else. Yeah, say I delete this. So what happens? My f moves here. Then you can just say if r is less than f, that is if the position of r is less than the position of f, that means there are free positions in between. So you can add one more condition. If r is less than f, then what you can do, you can just add d here. So this is how a circular queue works. Then you're going to reassign r from here to here. Is everyone fine with this explanation? You can think about the assignments later at the end, because my battery is going to die soon. So focus on class for now. Is everyone fine with this explanation? Yes or no in the chat? Okay, you want me to repeat it again? Um, okay, sure. So it is exactly the same as a queue, but you're gonna, do the logic a little different. So what you're gonna be doing is when the queue is full, right? Give me a second. My phone lock. So, yeah. So it's a normal queue. What you're gonna do is say all of them have values inside, and your F is here and your R is here. So when you delete something, you're gonna move your F here. So what you're gonna do is you're just gonna check if R is at the end position. So if R is at size -1 and F is not at the 0th position, F is not equal to 0. So that means there are free spaces here. There is a free space since F is not occupying the first position. So what you can do is you can add another element here and you can bring R here. So this is how a circular queue works. So now how do you say if the queue is empty or full? If R is, less than F -1. You can see R is less than F minus, I mean, if it is less than F -1, there are free spaces. Now R is equal to F -1, meaning it is full. So this is how you work with a circular queue. I'll explain a bit more in detail when we go into the code. But did you guys understand how a circular queue works? You're just gonna write some extra logic on top of a normal queue so that it doesn't waste memory. Got it? All right. So we'll go into the code. This is some Java code. You don't have to worry about the Java syntax. Just focus on the logic part. Since half of you are C++ and half are Java, right? You don't have to worry about what is this public void display and all that. Just focus on the logic. I'll explain the logic to you people clearly. So what I'm doing here is I'm making a new queue, and in this new queue, what am I doing? I am here. I am setting the size of the queue, and I am initially setting the values of front and rear to -1, right? So what is the size going to be? It is 5. So my queue is of size 5, and my front and rear are at -1. So this is exactly what we did in the Jamboard. So far so good. Now let us see the logic to add an element. Okay. So that is called NQ, if you people remember. So what I'm doing is, if front is equal to 0 and rear is equal to size -1, this is the condition that I told you, right? If front is equal to 0 and rear is equal to size -1, that means the entire queue is full. That means the entire queue is full. So the next condition here is, if rear is equal to front -1 modulo size -1. I'll explain this to you people now. All right. Okay, let's go to 17. So consider okay, consider a small queue of size 3. So 0, 1, 2. So the size is going to be 3, right? So now what are we doing? So if rear, let's look at the, if rear is equal to front -1 modulo size. All right. Yeah. If Now currently say my rear is here, my rear is here and my front is here. So what is this going to do? My rear is going to be 0, my front is going to be 1. So my condition is r is equal to f minus 1 uh, and modulo of size minus 1 for this front minus 1 only, right? So let's see that. So now my size minus 1 is always going to be 2, right? So what we're going to do is we're going to do modulo 2. So uh, what this is going to give us is, now it's going to be 1. 1 minus 1 is 0. 0 modulo 2 is it's going to be 0. So now is my r is also 0. 0 is equal to 0. So this means there is no more place for you to add any more elements because it is full. So I'll tell you why that modulo size minus 1 is added. So now imagine the same array with 3 elements, okay? So my f is here and my r is here. Uh, Sorry, my r should be here, all right? So now, um, give me a second. Oh, sorry. Uh, just give me a second. Mhm. Yeah. So, so now what is going to happen? So my r is at position what? It is at position 1, and actually, I think size minus 1. It's been a while since I wrote this code. Actually, give me a minute. Modulo, I'm going to get that. And minus 1 is going to be 1. All right, got it. So I did this for a reason. So now you know that in our case here, right? It can only be 0, 1, and 2. So front is never going to be crossing this uh, second position, right? So one way for you to keep looping through a fixed boundary is to use a modulo. So how are you going to do that is, now if you see my f is at position 2. So 2 minus 1 modulo 2 is going to be 1 only. So my f is never going to cross this threshold of 0, 1, and 2. So say my f, for some reason someone writes buggy code and then f goes to 3. What is going to happen? 3 minus 1 modulo 2, it's going to come back to you know 0. So 4 minus 1 modulo 2 is going to come to 1. So this is just to prevent this exception called index out of bounds. So I think that is Java specific. You can even remove this to make it less confusing. Hmm? Um, yeah, I can remove this to make it less confusing. But you guys just know that your R can never just be behind F. If it is just behind F, it means the queue is full. All right. So now we just write this condition so that we know the queue is full. If front is equal to 0 and rear is size minus 1, or if rear is just behind front. So if that is not the case, you're checking is front at minus 1 position. I already explained, if front is at minus 1, it means queue is empty. So you're setting front to 0, rear to 0, and you're simply adding the data. So you forget this queue dot add you know, these are just some, wait a minute. Circular queue. Okay, yeah, this is because we're using that dynamic array, which is an array list. So you cannot use the normal syntax. So just forget about the syntax. We're just adding the data in the position of rear. You know, add data to position rear. That is what this basically means. Else, if you're checking if rear is equal to size minus 1 and front not equal to 0. I explained this condition here, right? If front is not at zeroth position, wait, I think here it's a bit more clear. If front is not at the zeroth position and R is at the last position, you're just going to say rear is going to be 0 and you're adding the data. If not, it's really simple. It's just like a normal queue. Rear is equal to rear plus 1, and then you're simply saying while front is less than or equal to rear, add this data, because this is the normal condition for a queue, right? When front is less than rear, you can add data. So here we are checking the other conditions above. So if you remember the first class where I taught you guys if else, you have to go priority wise. So our first priority, we are checking if it is full. If it's full, you're not going to add anything. Then you're checking if it is empty, and then you're checking if, you know, our rear is at the end and front is not at the starting position. Then it is possible to add. And last is the normal condition. All right. All right. So now let's go to deletion. So for deletion, I'll tell you how it works. If front is at -1 position, you know that the queue is empty, correct? So this is for deletion. So what we're gonna do is you are just gonna take the value at the front to display that this element has been deleted, and you're checking if front is equal to rear. So this means that there is only one element. Front is equal to rear means only one element is there. So you are setting it back to -1, emptying the queue. Or you're saying if front is at the end, here if you see front is at the end, just imagine rear is somewhere here and front is at the end. So you need to circle back the front to the 0th position, right? So that is why we are writing this front is equal to 0. Else you're simply writing front is equal to front plus 1. So as you can see, it is just like a normal queue, except you can see this one extra condition is added for deletion. And you can see for addition, you have two extra conditions, one extra condition actually. You have just this one extra condition added. So is everyone fine with this code, or if you have any doubts, I can explain. I mean, the logic of circular queue, you need to be fine. The code, you can write it by yourself. So it is a regular queue. You're just adding one extra step. So I'll show you how it works. This program, we'll just run it with some inputs. So as you can see here, I'm directly just doing this. So this input is not necessary. You can see I'm adding 14, I'm adding 22, I'm adding 13, I'm adding -6, and then I am displaying it. Then I am deleting one element. So let's just run it and see what happens. See, the size is 5, right? So first I added 14, 22, 13, and 6. And then I deleted 14 and 22. So now I have just 2 elements, meaning I can add 3 more elements. So what am I doing here? Sorry, I think the size, yeah. So I can add 3 more elements. So what are we doing? We're adding, so we have 13 and 16. We're adding 3 more elements. 13 and -6, we're adding 3 more elements, 9, 20, and 5. So after 920 and 5, we are trying to add 20, but we are not able to. So in the old queue code, if you remember, after deleting, we could not add. But here we are deleting and adding more. So that is just because of two if conditions, where you're circling back the front and rear. So this is why it's called a circular queue. Is everyone fine with this? This is something you can just read on by yourself, but I just want you to be clear with the concept of a circular queue and how it works and what are the conditions. Yeah, okay, deletion, right? I'll explain deletion again. So here, if you see deletion here, if front is equal to -1, let me just you know explain it to you on Jamboard. Maybe it will be a bit easier there. So first I'm saying front is equal to -1. Let's look at the Jamboard. So if front is -1, uh, you know, if f is equal to -1, r is equal to -1, it means f is equal to -1 means the queue is empty, right? So that is what we are saying here, queue is empty. But here we are saying if rear is greater than or equal to front, oh sorry, this is for display. Sorry, the same condition is here. So this is empty, right? You cannot delete. If front is equal to -1, you cannot delete it. So next condition, if you see, we are simply getting the value that is in front and storing it inside temp. You forget about that. Now you see front is equal to rear. So what is front is equal to rear? So I'm adding one element, say a, and now after that my f is going to be 0, my r is going to be 0. So my front and rear are pointing at same element, right? Front and rear are pointing at the same element. So meaning there is only one element. After deleting that one element, you will have to set f and r back to -1 because it is empty. So that is this condition. If it is equal to the same value, then you are going to set back to the default state. So next one, you see, if front is equal to size -1. So I will explain this to you. If front is equal to size -1, all right. So just say r is equal to this element. You have b, and you have c, and you have my front here. After deleting this element, right, my f is currently at size -1. After deleting this, f is going to circle back to the 0th index, correct? R is not changing, but f is going to circle back to this position. So what we're doing is we are setting that to 0. So now you know that if this condition fails, all right, if that condition fails, you know that f is not at the ending position, but it is somewhere here. It is not at the last position. So what you can do is you can simply do front is equal to front plus 1. All right. So that is deletion. So you just need to cover, if it is empty, you cannot delete anything. You have to cover that one condition. Here, if you see this empty condition, you have to cover. Then you have to cover if only one element is there. Then you have to cover if front is at the last position. And lastly, you have to cover if it is not at the last position. So is deletion fine now? All right. So even insertion, you just need to cover the same steps. If it is empty, what do you do? If it is full, what do you do? If rear is at the starting position, what do you do? If rear is at the ending position, what do you do? So that's all you need to think about for a circular queue. So we are done with circular queue for now. We'll jump into searching. All right, let me just check my battery. I got 32% left. We should be able to do searching. So this is actually something that you will be using in your DSA. Till now, I taught you the basics of what data structures you'll be using, but now we'll be going into the algorithms. So these algorithms are going to help you solve DSA questions on CodeChef, HackerRank, or any other platform that you're using. So searching basically means, no, let's jump here, slide 20. So searching. So searching basically is where you go through a data structure. You're not going through an array. Just remember, you go through a data structure. This is not an array. Just this is some data structure. It's not an array. It could be a stack or a queue or a linked list or anything. And it has values A, B, C, D, E. So you go through this data structure searching for a value. I will call it X. So you will just see if X exists in this data structure. And if it does exist, you're going to return the position. You're gonna return the position. I'll just make it X so that you know. So if X exists, you're gonna give the position. If not, you're gonna say it is not found. That is what searching basically means. It's not exclusive to arrays, but it can be done on any data structure. Is everyone fine with this explanation for what searching is? All right. So I actually reached the limit of my jam slides. Let me just delete one. Okay, just give me a minute. All right. So let's try to do. There are two searching. Yeah, there are two searching algorithms which I'm going to teach you. There are many more searching algorithms, but I. Oh, it's not clean, is it? Give me a minute. So yeah, there are two searching algorithms which we will be going through today. One is called linear search and the other is called binary search. So I will tell you what these are in detail first, and I'll tell you the prerequisites. So a linear search, I'll just call it LS. Oh, sorry. Yeah, I'll call it LS and I'll call it BS, binary search. So a linear search can work on unsorted data or sorted data. Unsorted or sorted. It works on both. And I'll explain what time complex. No, I don't want to explain it. It'll take time. Okay. Time complexity is basically how long your program takes to run. So if you have one for loop which iterates n times, a for loop that has n, its condition goes up to n times, the time complexity is big O of n. So you can just say it takes n units to run because you're running the code n times. So the smaller the small, you just have to run your code for a smaller number of time. You don't want to run it for a large number. You don't want to run it for say 1000 or 2000 when you can do it in just 10 or 20 iterations. If your for loop just has to go through 20 values, that is better than having to go through 1000 values. It saves computing time. So that is time complexity. For now you can just remember that. I'll if you want, I can teach you that in the next class, but I'll tell you the time complexity of these things. So our time complexity of this is going to be n. For n values, it's going to run the code n times. For n, the average case, it can run less, it can run more, but I'll just say the time complexity for the worst case is n. I'll explain why. And the time, this binary search only works on sorted data. It does not work on unsorted data. And the time complexity of this is log n. So I will tell you why also and how these work. So is everyone fine with it so far? Can I get a yes in the chat if it is? All right. Give me a second. I'm erasing another jam slide. All right. We can move on to binary search. Yeah. All right. I'll you know show you guys what it is. So linear search is what it's gonna do is say I have some values and this is an array. Say I have 10, 15, 5, 3, 20, and 1. So this data is unsorted and I want to search for 3. I want to search for 3. So what I'm going to do is I'm just going to come here. I'm gonna I'm gonna check with this 10. Is 10 equal to 3? It is not. I'm gonna move to 15. It is equal to 3. It is not. Is it? It is not. Here it is equal. So the index is 0, 1, 2, 3, 4, and 5. So I'm just gonna return this third index. So this is a linear search. So why is the worst case condition n? So what if the 3 I'm searching for is in this position and this is say something like 6. So this is not going to be the answer. This is also not going to be the value. And at the last position, the nth position, I'm going to get it. And my answer is going to be 5. So I had to move through n locations. I had to perform the operation n number of times to find the value. That is why the worst case is n. So for this is fine because it's just 5 values. So when you're working on a real-time project, your database is going to have tens of thousands of values. Are you going to go through tens of thousands of lines to find some one line? It's not really that efficient. But this is one searching algorithm that you can use for DSA. I mean, since you're not going to be working with tens of thousands of values, this is one thing that you can use. But I'm just saying why n is not a good uh, time complexity. So is everyone fine with the logic for how a linear search works? Can I get a yes or a no or a maybe? Okay, I got a no, and I will. Okay, kind of a no. I'll show you guys how it works on code. All right. C plus plus color online. Which one was I using last time? Yeah, this one. I'm typing in the dark, so I might make some mistakes. So bear with me. I'll show you how it works. All right. So first, I'm gonna have my n. Oh, first I need to create int n, and I'm gonna make another one called search p. All right. I'm gonna say int a of I'll do that in a bit. Then actually cn of n. I'm reading the value of n and I'm making another array of size n. All right. So I'm saying cout enter the elements of the array, and I'm gonna do this. And end L is just to give a line break. So now I'm gonna do a for loop. For int I is equal to 0, I less than n, I plus plus. I'm simply going to do cn array of I. So I'm reading the elements. I'll give some comments. So now I will show you. The next thing is cout enter the element you want to search for. And I'm going to write search. All right. So now I have all my data. So next part is going to be the logic. I'll show you guys the logic. All right. So now, what is this? Linear search. I'm just gonna write a for loop, and I is equal to 0, I less than n, I plus plus. So this for loop basically just goes through every single element in the array. What I'm going to do is for each element, I'm going to write an if condition. If the element in the array is equal to search key, and say, you know, then I'm going to say cout, element found at index, and I'm going to leave a space and I'm going to write I. All right, and I'm going to break. Now, outside the for loop, I'm going to write a condition saying, and I'll just make it simpler for you guys. I don't want to make it tricky. Int is present. I'm setting it to 0. All right. So this is present is set to 0. And if it is present, I'm going to change it to 1. Is present is equal to 1. All right. And I'll even make it even more simpler. And I'll create another one called position. All right. I'm going to say position is equal to I. Right. So this is my search logic. So now to give an output, I just have to say if is present is equal to 0. That means this we never made a match, and this is present was never set to 1. It is set to 0 only, meaning it never went into this condition. So what you're gonna do is you're simply gonna do cout element not found, and else we are simply doing cout element found at index space, and I'm gonna say I. So this is the logic. I'll run it and I'll explain it to you guys once it runs. Okay. Yeah, this is the position. Yeah. It's not asking me for anything. Fine, let's just try 5. Oh, I actually missed out. Yeah, I stop it. So I actually missed out a C out, so it made it a bit confusing. C out, enter number of elements. Now it's gonna run perfectly. Hmm. Yeah, there's semicolons. All right, cool. So let's say I have 5 elements, and I'm entering 1, 5, 2, 3, and 4, and I want to search for 2 element found at index 2. You can see 0, 1, and 2. 2 was found at index 2. So let's run this again. I think the example was quite bad. Let me just change it up to maybe 10, 40, 30, 73. All right. So let me search for say 70. 70 was found at index 3. So 0, 1, 2, and 3. It is found at index 3. So now we're going to search for something that does not exist. So I'll just make it 3 elements this time. 1, 2, 3. And I search for 5. Element not found. So how does this code work? So this code basically, you're reading an array. You guys know how to read an array. So now I'm saying this I is equal to 0, I less than n, I plus plus. So if we, let me just open my notepad for this. So you have your index 0, 1, 2, 3, 4, 5 up to n minus 1, correct? So these are your indexes. So you're writing a for loop for this condition. If you see, the for loop is for that only. It starts from 0, it goes till n minus 1, and it goes one step at a time. And you're simply comparing is the element at position 0. I'll even make this better for you guys. Yeah, at position 0, say I have A, I have B, I have D, I have E, I have F, I have okay. So now say I'm searching for something called X. So it's going to go to this position and it's going to search. Is A equal to X? Is it equal to X? It is not equal to X. So it never goes inside this. And then what you're going to do is B equal to X. It is not. Until it finds X. Once it finds X, you're setting position to the current position where X was found, and your setting is present to 1. You're just changing the value so that you know it is present, and you are breaking out of this for loop. You don't want to run this anymore since you already found the element, and now displaying is just a matter of it if it is present or not. If the value is 0, it was never found, so the value was never updated, so it is not found. Else you're just displaying the position. So this is linear search. Is everyone fine with this? Uh, can I get a yes or a no? All right. Especially from the people who didn't understand the logic, I think one person said yes from there. The other person who said kind of. Do you understand it now? All right, that's good. So we'll move on to binary search really quick. It shouldn't take long, so bear with me. So I'll teach you how a binary search works on this one itself. So as I said, a binary search only works on sorted things. So it should be sorted, say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It can be sorted in ascending order or descending order. You just have to change your logic. But why should it be sorted? So now, say I am searching for an element 8. So if I have to search for it using my linear search, I have to come here 1, 2, 3, 4, 5, 6, 7, 8. I have to do this compare operation 8 times. But what I can do is in a binary search, oh, the power is back. I think we can continue with the light heart now. Just give me a second. Let me connect the charger. Okay. So now I'll tell you how this works. So what you're gonna do is you're gonna take the indexes. So the indexes are gonna be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're gonna take the number of positions. Okay, you're not taking the values, you're taking the number of positions. So what is 0 plus 9? It is equal to 9. So what is 9 divided by 2? It is 4.5. But in terms of integer, that is going to be 4, right? So you're going to you're going to have three variables called high, low, and mid. So your high, let's go low, high, and mid actually. Low, high, and mid. So now your low is the starting position of your array. Your high is the ending position, and mid is calculated. So your low is equal to 0, your high is equal to 9, and your mid is equal to low plus high, the whole divided by 2. Okay, so for 0, I mean we can say 0 plus 9 by 2 is equal to 4.5. The integer value is 4. So you're going to take the value at 4. So the value is going to be, so mid position is 4. Value of 4 is equal to what? 5. So the value at position 4 is equal to 5. And you want to search for 8. 8. So now, is 8 smaller than 5 or greater than 5? It is greater than 5. So you don't have to search this entire section, since you know everything on this side is smaller. You're not going to even touch that section, you know. So this side you're not touching. So what are you doing? Now you're just going to check, is 8 equal to 5? It is not. And you found that 8 is greater than 5. So you're just going to do one small change here. Give me a second. Yeah. So the change is, since it is on the right side, you're going to say low is equal to mid, high remains as is, and now you're going to compute mid again. So mid is equal to what? 4 plus 9 divided by 2, which is going to be what? 13 by 2, which is 6.5, which is 6. So now you're going to check at position 6. Is 7 equal to 8? It is not, but and 8 is greater than it. So you don't have to search this part also. This also you don't have to search. So you just have to go through this remaining part. So you have the same condition. What is it? You have your low is equal to mid, and your high is equal to same, and your mid is equal to, now my current uh, low is 6, so 6 plus 9 divided by 2, which is 15 by 2, which is 7.5. So 7.5 becomes 7. So you're going to check the value at 7. It is 8. 8 is equal to 8. Element found. So how many times did we do this? We did this only 3 times. And we found that 8 is present, right? So instead of doing it, multiple times, like we had to do it 8 times with a linear search, the comparison. But here we have only done it 3 times. So did you guys understand how this works? So you're basically just going to see if it is on this side or that side, and you're gonna arrange based on that. I will show you one condition where it's not. Do you guys prefer it on a notepad or on Jam? Can I get an answer? Notepad or Jam? Can you just type it really quick? So we got one notepad. All right, then we'll stick to notepad then. My artistic skills aren't really great, so Jams are quite tough to work with. So I'll give you another example. Say I want to search for 3, what happens? So here you can see that I was setting low to mid because it was on this side. But say I'm searching for another one. I'll cut and paste this above for now. This is fine till here. It's fine. Control X, and I just keep it here. Right. So say I'm searching for 3. Search for what is gonna happen. So now I have my value at 4 is equal to value of fourth index is equal to 5. Now is 3 greater than 5? It is false. So is 3 equal to 5? It is false again. So 3 less than 5? It is true. So now it is less, right? So you're going to move, you're not going to search this entire part. This part is useless for you. This part is useless. So what you're going to do is you're only going to search this part. And actually, I missed something out when I was teaching you before. Low is not equal to mid, actually. Low is equal to mid plus 1, because you know that 5 is also not equal to the value, right? You don't need to use that. You can only use this much of the array. So same way now here we'll do it properly. So you know that 5 is not equal to that. So your low remains as is, and your high becomes mid minus 1, because this is the current mid and you want your high to be here because you're only searching till here. You're not searching the entire thing. So this is how you do it. This is the logic. It's a bit broken, but I'll code it and I'll show you guys. So is everyone fine with the explanation so far? If you have any doubts, we'll clear it off in the program. All right, I think we can manage with it. I don't need to switch to Wi-Fi. So I'm not gonna write the first bit again because this is just to take inputs. This is totally fine as is, but I'll make one small correction here. In ascending order, this is really important. You can do it for descending order, but the logic will be reversed. So I'll show you for ascending order. The team can note down one assignment problem, binary search for descending order. You can note it down. Let's try to code this thing. So first is I'm creating 3 variables: int, low, mid, and high. I'm setting low to 0, high to n minus 1. This is the initial value, the end of the array, n minus 1. And then mid is equal to, okay, we'll go like this. Low plus high divided by 2. Now we'll do a while loop. While low is less than or equal to high, because if you can see in our code, low always had to be lesser than high. If low crosses high, if high is here and low crosses it, that means there are no more elements in the array and we're still trying to do something. So we're doing while low is lesser than or equal to high to this, right? And I'll just we already have a search key in position. All right, that's good. So what we're gonna do is mid is equal to low plus high divided by 2. So if array of mid position is equal to search key, I'm saying is present is equal to 1, position is equal to mid, and break. I am coming out of the while loop, all right? Because I found it. Else if element at mid is less than the search key, what am I going to do? I'm just going to say low is equal to mid plus 1, all right? And I'm gonna just be done with it. Else, if it is not equal to here, if it's not equal to, or if it is not less than, what is the remaining value? It is greater than. If it's not less than, if it's not equal to, it is greater than. So you can go with an else as is, but for people to grasp the logic, I'll write an else if. An else would work perfectly fine here, but I'm going with an else if array of mid is greater than the search key. What are we doing? We're simply going to do high is equal to mid minus 1. So now this is the entire logic for the binary search. So what we need to do is we just need to say again if is present is equal to 0, cout element not found, else cout element found at position um, position. All right, so let's see if this works. We'll just try it for 3 elements. 1, 2, 5. I'm gonna search for 2. Position 1, that's perfect. Again, 3 elements. 1, 2, 3. 3. Perfect. I'm just making sure it works for all indexes. Give me a 2, 3. Position 1. Perfect. The last one. 3, 1, 2, 3, and 4. 4 is perfect. So I'll give you a bigger example and then we'll try to uh, understand how it works. All right. I'll give 10 elements and I will actually show you the output and then I'll show you something good. I'll give 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, right? And I'm gonna search for say 80. It's found at position 7. Perfect, it works. And I'll show you how this logic works. Same way, initial conditions, low is always going to be 0 because array starts from 0. End is all high is always going to be n minus 1 because this is the last element. And the mid position is calculated by low plus high by 2. And you're just going to do it until and unless low is less than or equal to high, because low can never be greater than high. So until that condition you're going to do it. And then I will we're just calculating mid, and we're checking if the element is found, we are giving the position. If not, we are making the necessary modifications. I'll show you something good actually. What we can do is we can just make some C out, right? C out, low, and uh, let me just make an enter. I'll show you the values and how it works. Low is low, mid, high, and such. Mid, high, and such. I'll show you how it works. So mid, high, for each loop we can see how it works. So I'll do it for 5 elements. Say 1, 2, 3, 4, 5, and we'll search for 4. No, we'll search for, yeah, 4 is all right. So here you can see my low is at 0, mid is at 2, and high is at 4, and search key is 4. Uh, then you see what happens. Now, what is at my position 2? Actually, I think I'll give some enders. Let's see. You can see at first low is equal to 0, your high is equal to 4, and mid is equal to 2. Perfect, right? The search key is 4. So what is at position 2? It is 3. So now 3 is less than 4. So if you see here, if 3 is less than 4, mid is being up, low is being updated. You can see low is becoming 3 now. Why did it become 3? Because this is mid. 2 plus 1 becomes 3. So now you see 3 plus 4 makes 7. 7 divided by 2 makes 3.5, which is 3 again. Now you're checking at position 3. It is 4. Since it is at position 3, search key and this match, and you're simply printing 3. This is how the program works. If you want, I can even show you the other condition. Give me a minute. 1, 2, 3, 4, 5, and I'll give say 2 this time. You can see again, 0, 2, and 4. Now search key is 2. Now what is that second position? It is 3. 3 is greater than 2. So what are we doing? We are updating. See, low is same, mid is going to be calculated, but high got modified. High became this mid minus 1. So it became 2 minus 1. High became 2 minus 1. So 0 plus 1 divided by 2 is 0.5, which is 0. So we are going to search at position 0. It is 1. It is not there. So now, is 1 less than 2 or greater than 2? It is less than. So you're going to update low's value. Since, 1 is less than, here you can see, since 1 is less than, you're updating low's value to mid plus 1. So mid was 0 before, so mid becomes 0, low becomes 0 plus 1, that is 1. High was 1, that is still 1. So 1 and 1 make 2, 2 by 2 makes 1. So at position 1 we have 2, we are coming out. So this is a binary search. Is everyone fine with the logic for binary search? I even showed you guys how the values are being updated. If you have any doubts, I can still go ahead with it. So everyone is fine with binary search, right? So that is splendid. So we are done with searching algorithms. Okay, you want me to repeat it again. So can you tell me which part you want me to repeat or why you're having that doubt? If you tell me, I'll go through that again. So the entire binary search part you're having a doubt, right? All right, I'll go through it once more really quick. If you still don't understand, let's why don't you attend the doubt session on Wednesday? Then we can go through it a little more in depth. All right. So I'll tell you how this works. So look at this. So you are going to find the middle element. So middle element is found by taking the first position 0 and the last position 9, adding these two, 0 plus 9 divided by 2, which is 4.5. So 4.5 integer value is 4. So you're taking the middle element, which is at position 4, the value is 5. And you're searching for 3, right? So 5 is greater than 3. 5 is greater than 3. So this entire part you don't need to search because you know that 3 will not be there. It is a sorted array. So what you're doing is you are simply going on this side. So to only do this side, your low does not have to be updated because low is same, but your high has to be updated. So what you're going to be doing is you're setting high is equal to mid minus 1. So mid value minus 1. So this is going to be your high. So you're only going to search in these. So forget these ever existed. So these don't even exist at this time. You don't need them at all. It is not there. So what are you going to do? 0 plus 3 divided by 2, it is 1.5. It is going to come to 1. So is 3 equal to the element at position 1? Is 3 equal to 2? It is not. But you know that 3 is greater than 2. So what you're doing is you don't need this entire part. So what you're doing is you're updating the low value. So low is updated to mid plus 1. So mid is currently 1, right? So low becomes 2. So then you don't need this part of the array. You don't need that part. So now this is your low. Low is 2 and high is 3. So 2 plus 3 is 5. 5 by 2 is 2.5. 2.5 integer value is 2. So what is at position 2? It is 3. So is 3 equal to 3? It is equal. So the value is at position 2. So this is a binary search. So our logic, if you see, it is exactly the same. I'll remove this. You see here, you're saying while low is less than equal to high, because if low is greater than high, if the starting position is greater than the ending position, there is no array. There is no array. So that is the condition. So what you're doing here is you're saying mid is equal to low plus high by 2. If mid is equal to the search value, you're saying it is present and you're giving the position. If the value of that mid is less than the search key. It means the array, it is on the right side, it is on the greater side. So you're saying low is equal to mid plus 1, or if it is greater than, it is on the left side, which is the lesser than side. So you're saying high is equal to mid minus 1, exactly what we did in this notepad. So are you clear with this now? So if you're not clear, you can post this doubt in the doubt session channel of the Discord, and we can do it on Wednesday if it's still not clear. But okay, all right then. So this is it for today's class.
Um, okay, yeah. Thank you, Akshay, for such a great session. And I would request everyone to please stay for a few minutes. I have a few announcements. So, yeah, first of all, we have a good news that Coach Chef has agreed to partner with us for this DSA Bootcamp. So, yeah, the contest at the end of the event will be taking place on most probably on Coach Chef itself. So, yeah, that's one good thing. And second thing is, everyone please do join us on any one of these. I'm copy pasting them. Just give me yeah. So since a lot of you did not receive timely updates last time or miss the emails, here are the links to our Discord, Telegram, and WhatsApp. We do prefer Discord, but in case you're not comfortable with it, there is also an option to join our Telegram or WhatsApp group. Just join one of these at least so that you get timely updates about whatever we are posting. And next thing is ki for those who did not receive the document and all details regarding the assignments and everything, so please do check your spam and bin folder once. Although it was sent through a Google group, you were all added to a Google group, so there's no chance of it going in spam, but maybe it could have gone. And in case it's still not there, so I am pasting the link to our form once more. Just open the form and see if you it shows that you have submitted your response to the form. If not, just please submit it once more so that we receive your email ID and details. And just fill it once, right? So we'll make sure that all of the contents reach you timely. And um yeah, after this, I just wanted to say that yeah, we will also post the assignment document on our Discord DSA CP channel. So make sure you do join our Discord. And yeah, for the Java session is like we could not do it in the previous week because of time constraints. So are you guys still up for a Java revision session? Like if you are, just drop a yes in the chat box. Like if we have enough people who would be interested in taking the Java session just to know and understand the syntax of Java, I'll be taking it on Monday evening at 7 p.m. So please do join for that if you want to, brush up your Java skills. After that, you'll find that solving assignments will be much easier for you, and Java is a go-to language for practicing DSA other than C++. A lot of companies test their Java.
Also, Shalini, what about the feedback form in case people have
Yeah,
trouble?
yeah. We will send out a feedback form as well, along with the contents. Actually, we did send it out to a few people. Those who received the mail must have received it. So yeah, we'll be sending out all the materials again to all of you. So make sure if you have any kind of feedback for this session, like maybe if you could improve it in some way, just let us know through the form. It's anonymous, so you don't need to worry about anything. Just post whatever you feel about these sessions. And once more, I'm pasting these links. Please join them, and please do fill out the form if you haven't. And yeah, that's it. See you on Monday for the Java session.
So 1 minute. So if you guys have any trouble with my teaching, so feel free to give feedback so that I could teach in a way that you people can understand. So whatever problems you have in understanding what I'm teaching, so if you can give feedback, the sessions will only get better. It will be more fine tuned to your understanding. So that's why. So feel free to give feedback. So yeah, that's all I wanted to say.
Yeah. All right. So uh, just copy paste these links if you can't open them right now. It would be helpful later on. or just join one of these groups. So yeah, that's it from our side for today. See you all tomorrow at 7 p.m. for the next session. Thank you, everyone. Also, in case anyone has any queries about attendance, so don't worry about that. Attendance is being taken through an automated extension. You don't need to fill any forms. The moment you join and the moment you leave, we have a record of all that. So nothing to worry about. Yeah. Thank you, everyone.